A little bit of background, I wrote the first lines of code on this Apache Druid project many years ago, so I'm a technical person by nature. Coming up, I work at Imply, which is a commercial entity around this Druid project. We do a bunch of stuff, and I'm going to talk today a little bit about what we call immediate infinite zoom. This is kind of working with real-time data to understand what's going on, and it's a pattern that we've been seeing as we've worked with customers, worked with data, and everything. I want to introduce it to everyone. So what do we mean when we say Imply delivers immediate infinite zoom on your data? Well, we're talking about an interactive kind of visual experience, but that doesn't kind of really get to the heart of it. That's not everything. Really what we're talking about is that we see that when people work with data, the way that they engage with it, the way that they interact with it, it always starts kind of at a high level. You look at the whole, you look at aggregates across everything. You step in, maybe drill into a little bit, look at, according to some angles, look at it from one angle or another. But at the end of the day, if you don't have access to the very fine-grained details, all of the things down at the very bottom level, you can't really make decisions. You can't understand what happened. You can't drive to conclusions. And so what we've seen with patterns with all of the customers that we work with, the people who have adopted Apache Druid, is that they tend to be trying to tackle this challenge of having a very large data set, needing to see it in aggregate at the whole, drill down at various levels, and get down to that core nugget. But talking a little bit about this, not in terms of our product first, I'm going to talk in terms of a metaphor. And specifically, I'm going to talk in terms of Google Maps. Now, Google Maps is not a customer of ours. They do not use Apache Druid as far as I know. I'm not trying to say that they do. I'm talking about this as an explanation of the idea, the notion of immediate infinite zoom. And now think back to before Google Maps existed, before all of the mapping things. Like many, many years ago, if you wanted to drive somewhere, you had to have this paper map with you in the car. You had to open it up, look at where you were going, pull over to the side of the street, figure out what's going on, know all of this stuff. And it was not convenient. We can call it a not convenient experience. But as mapping got on the internet, and especially as Google Maps got out, it really changed how all mapping works. It changed how everyone thinks of mapping. It even, to a certain degree, almost killed the little local GPS market, because there was the whole GPS market, people helping you go around in cars and all that stuff. Google Maps just kind of destroyed that. Now, how did it do it? Think of the experience of Google Maps. You start with a map of your whole space, your country, state, whatever. You get context. You see what's going on with that. You pinch, you scroll. That's allowing you to shift your angle of viewing of what you're seeing. You can scroll down all the way to your local neighborhood. What's going on, where things are happening, see the buildings around you. But then they took it to another level and actually took it down all the way to Street View, where you can see exactly what you would see if you were there in person and get a sense of the world around you. Now, this I called a metaphor. It's describing this notion of immediate infinite zoom. It happens immediately. When you zoom, it goes quick. I mean, every once in a while, if you have bad internet, you zoom and then all the panels disappear and you're like, what do I do? And then you sit there annoyed until it actually loads. But it's immediate. The immediacy of it is an important part of that experience. But also that ability to kind of shift around and look at everything is incredibly important for gaining context on where you are, gaining context on what's going on, and guiding yourself to a place. And these are kind of examples of this immediate infinite zoom. You see the broader context as a whole. You can zoom in to independent levels, and you can get all the way down to the finest, most granular idea of the world, which is what you would see if you're there in person. Now, Google Maps is using our Earth's data, the map data of the world, in order to deliver what we're calling an immediate infinite zoom experience. Most people don't have map data. Most people aren't trying to put maps out. They have their own data. But on top of their own data, there's still this need for an immediate infinite zoom experience. Talk through an example, manufacturing. If you're in manufacturing, your executives will want to see how many pieces are we creating, what's the defect ratio, how often are things going through QA being reprocessed, where do we have any issues with, as you get into the next level, you want to understand if there's issues with supply chain. Is there variance in delivery of products to different factories? Are there variances between the factories? And then once you've identified that there's something going on, you want to be able to get in and figure out, okay, what is actually going on? What's different here? What's happening in the data? And where is that? And to get that, you need to get down to that base level. And so on this manufacturing data, sure, you're not scrolling around a map, but you have different manufacturing plants. You have different product lines. You have different factory processing lines. You have different machinery. All of the things are in different locales. You might even have different management structure over different factories, and that can play a role in the efficiency or efficacy of certain things. And so in a map, you're scrolling around latitude and longitude and seeing what's going on and zooming in and out. But on a data set like this, you're looking at different angles of it. You're looking at who's managing the factory, which plant, what are things looking at, and that sort of stuff. Another example, this is a real-world customer example of a company called Ibotta. Now, Ibotta does cashback deals. You can get the Ibotta app, sign up for it, they'll send you deals, and if you go shop, you buy something that they sent you a deal with, you can get a cashback from them. Now, given that they give cash back, I think, I forget the actual stat, but I'm pretty sure they've given like $70 million back to people in cash. You can imagine that there are some actors out there that are maybe like, oh, I wonder if I can get cash without actually buying things. Maybe I can get you to give me money and I don't actually go and buy the thing. This is a problem for them. It's fraud, and so they need to be able to see this. Now, of course, if they can identify fraud at the point of sale, at the point that they're actually doing the cash back, that is best. And so they can do a programmatic integration in order to just see, is this person legit? Have they been doing things? What's going on? And they can do a programmatic thing just at the point of doing the cash back in order to validate stuff, and they do that. Now that's at the layer of an individual user. But there are crime syndicates, there's crime rings, there's people who come together. You can go and bot out users, you can create a whole bunch of users, you can do all sorts of things to where one user isn't the issue, it's a bunch of users doing something that is actually fraudulent. Now, in order to see that, you have to be able to see an aggregate. You have to be able to see what's going on at a wider view, and you might not even be able to notice that immediately at the point of doing the cash back. You need to be able to investigate more. And so what they can use us for, by having this experience of seeing all of the data, is you can look at the high-level aggregation. You can understand the trends, what's going on. Is there something that looks weird at the high level? Dive into it and be like, hey, is there a specific device that has suddenly spiked? Is there a specific thing that's going on? Is there some commonality that we're seeing causing oddities and changes? But then the fact that they have access to that granular data, they can go down to each independent transaction, it enables them, when they're doing this analysis to figure out what's going on, to go down and look at what actually happened, to make sure that what they're looking at is actually fraud and not just a user that managed to buy a bunch of things and got a bunch of money back. Which is an important part for them. And so for them, this notion of being able to see things at a high level, drill in and look at it across different angles and get down to that independent, highly granular data is incredibly important. There's a number of other companies. This is the standard logo slide of people who use your stuff. And there's a number of other companies who also choose to use Imply for this style of use case. And this is, as I mentioned earlier, this is a common pattern that we see across a lot of our customers, is this notion of being able to see aggregations as well as stuff all the way down to the fine-grained independent data. And we at Imply have this Imply Polaris project, or product. It is a SaaS product delivered on AWS and Microsoft Azure, and we call it the fastest path to this experience. Why? It's easy to set up. It's SaaS. You go sign up. Yay, you've got infrastructure running. You can use it via API or the built-in UI. And so you interact, you engage, you get it immediately. It's fully managed at any scale. One of the things that we've dealt with a lot with our customers is they have scale challenges, especially when you're trying to look at granular data as well as high-level data. It's really easy to have a lot of scale. It's cost efficient, at least that's what we're told, and it's also secure and resilient. But these are all the feature things up on the slide. Let me go ahead and switch to a live demo and show a little bit of the product. Now, this is the product. I'm, of course, already logged in. I have something set up. It already has some data in it. If you were to come to it, you wouldn't come and have it pre-populated with this data. You can create tables and load data, and you can run SQL. And there's these notions of dashboards and configuration of the dashboards. And so for this demo, I'm just going to dive right into a dashboard, and we're going to go back and talk about what this immediate infinite zoom kind of means. So what we're looking at, this is a manufacturing example. The data that we have is data about products that are being manufactured. It's, of course, manufactured data as well. Yes? No? Anyway. So it's fake data. You can see that we have some number of events. We have the number of products that are accepted. We have the number that were found defective. There is a yield, the number of products that were produced. The yield is basically accepted over produced, and the defect ratio is defects over produced. You can see that as far as this dashboard is concerned, we've got some geo data of where things are being created. We've got this other, line chart talking about the defect trends per plant. You can see the quality per plant, so broken down per plant. We then have here the different plant providers, and actually let me try and make that larger. We've got the material per plant here, and so there's different material providers for the plants. There's different materials that the plants are using to build their product. All sorts of stuff like that. And now, this is a dashboard you've seen before. I'm not showing you something you haven't seen before yet. We'll get to the part that's kind of special. But from this dashboard, you might say, well, I'm looking at the last hour. Let's look at the last 7 days. So over the last 7 days, we can see that there were a lot more things produced. And when we scroll down, we can see, oh my word, what is going on here? There's this massive spike. How did that get in there? Well, we want to drill into that. So let's go ahead. We drag, drop, filter. Now I'm looking at all of the things that happened inside of this time range. And the other things on the dashboard have updated in order to be drilling into this. When I keep going down, I see, whoa, this one plant, massive defect ratio. There must be something going on with that plant. Let me click on that and then see what else I can find. I see, okay, there's a silicone multi-layers thing. It seems to have an issue with the defect ratio. So there's probably something with that. And now I've gotten to the end of my dashboard, and I can't do anything more, right? And this is the problem that you generally run into with dashboards, is there's something that's been pre-canned, you've predefined it, you've got some things there. You get to a point, you're like, yes, I'm figuring things out, and then you're stuck because the dashboard's done. You can't see anything beyond that. So we've gone from the aggregate down to somewhere in the middle, but at this point, we haven't been able to go deeper. With our product, what we can do is for many of these panels, I can go into this expand panel and go into what we call the explore view. Now I have an ad hoc exploratory experience. This is the exact same data that we were running on. I can see stuff, and just to give you a sense of what the data looks like, if I switch to the record view, these are the actual raw records in the table that we're querying right now. So you can access all of it down to whatever grain of data actually exists there, and everything that we've been looking at has been aggregations of this data. And the interactivity and all of that comes from the performance and the speed of the underlying system. But anyway, so we've got this data, and we're saying, okay, Now we want to dig deeper. We can see that there's a whole bunch more dimensions over here. And specifically, we might say, well, is there something going on with specific machines? You could imagine. And when we sort by this, we see that yes, these two machines over here seem to be having massive issues with defects. Well, machines come from a different provider, so maybe there's something with a specific provider. Are they the same? Turns out, yes, they are. They're both this one advanced XF. So we might say, okay, it's actually this advanced XF machine. I don't care about which machine because it seems to be similar to that. But we've been looking at this one plant, at plant 4. Now, we have these machines not just in one plant, we have them in other plants. Are we seeing the same problem in those other locations or not? Well, let's find out. Let's stop right now. We're filtering on plant 4. Let's stop filtering on plant 4. And we can see that at plant 0, we actually don't have an issue with the defect ratio, while plant 4 has the issue. So this specific machine is deployed in one plant and it's working fine, and in the other plant it's not. So there must be something different between these plants. Taking this on more, we can go in and be like, well, there are configurations of these machines. I wonder if there's a difference in the configuration between them. And we can see that plant 0 is using this custom multi-layer configuration, where plant 4 is using this vendor default configuration. And so now at this point, we've now gotten to the lowest level of difference in this demo data. But ostensibly, if this was what happened in the real world, you could be like, okay, plant 0 has this custom configuration, plant 4 doesn't. There seems to be something up with these, so I need to go and call the people at plant 4 and the people at plant 0, figure out what the custom configuration is, tell the plant 4 people that they need to update their config, drive consistency through the system, and hopefully bring that defect ratio down. And this is a notion, this is kind of an example of just interacting with the data, seeing where it takes you and understanding where it goes. And it's made available because we have this raw data. We can get down to that raw data, see it at that level, and the interactivity of the system enables us to both see at a high level what's going on in the system, as well as drill down to that individual event basis. And that's kind of the immediate infinite zoom that I've been talking about. Okay, so that is our product. Going back into the slideshow. Oh, I've got to go through the build again. So how is all of this delivered? Well, this is a streaming conference, so as you might guess, there is often a stream involved. We have a direct connectivity, and actually we've integrated with Kafka since 2010, something like since it was first open sourced. We've had a very long history of integrating with Kafka, reading from it. We're a consumer directly on it, doing exactly once ingestion and all of this other stuff. But the overarching kind of architecture diagram is you have your data wherever it's coming from, whether it's coming from your client, your application, it could be another database, files, whatever. You would pump that through a stream. We can do batch ingestion as well, but taking it through a stream is often what we see because especially for the immediate infinite zoom cases, people tend to really care about what's happening now, and they want to know that when they're looking at the data, there's no question of, well, how old is this data? If I wait an hour, is the thing that I'm seeing, is it just going to go away because the data's old? Or am I seeing something that's actually in the real world? And so when you're trying to understand what's going on in the real world, you really can't have that lingering question in the back of your mind, oh, is what I'm seeing just there because the data's stale? How long should I wait for the staleness to go away in order to be able to trust this data? Like, it's a question, and you need to have that kind of up to the second, up to the millisecond view in order to truly be able to trust the data and trust that the data is telling you what's happening in the real world. So for these use cases, people tend to funnel things through a stream. Tends to go through a stream. You can throw your event processor on it. You can do your KSQL, your Flink. whatever, do pre-processing, decorate it if you want, do that stuff. At some point, it goes into our system, our SaaS product, which is what I was just demoing, Polaris. We have a direct connection with Confluent Cloud. If you have your own MSK, you have even Kinesis, whatever, you can connect it up, plug it in, funnel the data. You connect it up, and then that UI is delivered directly on the data. Now, a few other reasons to choose us, kind of getting into some technical notions and technical reasons, are one, we do schemaless ingest. And this means that your data can just be sitting on your stream, come in, we'll figure out what is there, we'll figure out what fields are there, we'll figure out the types of them and optimize for those types without you needing to configure anything. You just pump the data in and run with it. We'll do the streaming data processing, and it's the full life cycle of stream data processing. I actually shouldn't say too much on this slide because I've got slides that dig into each of these. There's asynchronous query and time series analysis. Let me go into the slides that dig into these. So with schemaless ingest and other systems, a lot of times you have to go and do DDL statements. You have to be like, well, I have this column and I have this column and I have this, and I need all of them to, it needs to always be a long or always be a string or always be something else. Or what we've found is that specifically for real-time data, and especially for this type of data where you're trying to understand what's going on in the real world, convincing all of the various people in your organization that this one field means this one thing, and it shall always mean that one thing, and it will never be anything different, and you cannot change it at any point in time is really, really hard. Different teams come up with their own definitions of things all the time. They, if you're talking about client-side instrumentation, some new engineer just joined the team at their old company. They called a widget, where maybe your own project calls it something else, and they just randomly go in, throw in a dimension, do stuff. Of course, you want to align those things, but you also need to be able to see the data and don't want that to break your pipelines just because someone threw that thing in. And so you can go the data governance route, but you also need to just accept stuff. Especially a lot of customers that we have deal with multi-tenant workloads. And in those cases, so like when you're dealing with your own data, you can kind of enforce some governance. You can try to get different teams to follow the same things. But when you're dealing with a multi-tenant workload, each of those tenants is going to come to you with independent tags that they care about, and the other tenants don't. And if a tenant comes and says that this is called a widget, another tenant comes and says, no, that is a module, and you tell them, oh no, we decided that it's called a widget, so you need to now call it a widget inside of your entire organization, they're never going to do it. They're always going to call it a module. They're always going to call it a widget. You can't change that. You just have to run with it. And so another point where this schemaless ingest really becomes important is the data can just come in. Whatever fields are there get indexed. They're accessible. And in this multi-tenant workload, for example, you can show customer A widgets, and you can show customer B modules, and the world is just happy, and we'll figure it out all on our own. The other thing, talking about managing the full data lifecycle of streaming data. Now, streaming data, there's having the data in the stream, there's processing it, that's great, but there's a bunch of other operational things that you need to deal with in order to create a product and deliver a product based on streaming data. One, we connect quickly. You just do some clicks, you get into Confluent Cloud, you get the data out of it. It's pretty simple. After that, you need to do some transforming and filtering. We can do relatively simple transforms, filters, and pre-aggregation as needed. As it gets more complex, we absolutely suggest people use Flink, use whatever. We're not in the game of replacing Flink. Like, complex stream processing is its own thing. That's not us. We take the data, though. We act as a consumer on the stream. We take the data, we persist it, and we optimize it for OLAP queries. We optimize it for analytical queries like what I was doing. And we have YouTube videos and all of that stuff about what we do. But we do indexing. It's a column-oriented storage format. There's vector processing on the query side in order to accelerate things, and all the things that people, all the technical buzzwords that people throw out for why their OLAP system is good. We do all those things. We then also, one of the things that we do, given that we consume from the stream at the same time, is we actually have, I think some people now are starting to call it compute and compute separation. So we have some nodes that will sit and consume from the stream and process that and run queries that happen on the most recent data from the stream. And we can have other nodes in the system that are just working on older data, working on your historical stuff and all of that, so that query processing of, if someone comes and does a big complex year-to-date query, it doesn't slow down your stream processing. You're not fighting for resources between those two things, which is really important actually as you get to higher levels of scale. There's another thing that often it's an important part of dealing with a stream that doesn't get talked about that much, but we allow for reprocessing the data and basically reorganizing the data in order to optimize for read. And so there's this interesting thing specifically with databases running against streams, or databases that are consuming from streams. And that is that when you're consuming from a stream, you want to avoid hotspots. You want your topics and your partitions in Kafka to not have hotspots. You want the data to be splayed out as evenly as possible so that you're consuming from the stream as evenly as possible around things. When you're running queries in a database, however, you actually want data co-located and you want hotspots. You want things located next to each other because you get better compression, you get better processing, you get aggregations to go faster, you get all sorts of benefits in terms of resource optimization. And so you actually want to co-locate data and have hotspots. And these two things are at odds with each other because if you optimize for the stream, especially very high throughput streams, you have to almost do just random hash partitioning of data in order to get near a very even distribution of events flowing across the stream. And if you start to semantically partition that, then you'll create hotspots in the actual topics, and you'll limit your ability to consume from your partitions based on the one hotspot that happens to be hit most. But then at the query side, you want to pull that data together. And this especially shows up in multi-tenant workloads once again, because you generally want data for tenants to be together. Your whale, though, is going to be really large. Your tail is going to be kind of tiny, and you want to move them around. And so one of the things that we do is we allow for reprocessing data. We call it compaction, but it's a process of basically data that was pulled in from the stream, maybe with a hash partitioning. We can then repartition it with the semantic partitioning after it's already gotten into the system, have it replace and optimize, and make that all queryable at the same time. And it's an atomic swap in terms of the repartitioning and adjustment and everything. And so from the user side, you don't see anything. You don't notice it. From the query side, you don't even know that it's happening, other than long-term it gets faster. But yeah, so that's kind of what this stay optimized thing is. And then there's always a need to backfill. There's always some issues that happen with data, like we are used very often in ad tech and analytics, and in ad tech as well, there's a bunch of fraud. There's a bunch of people trying to get money from advertisers without actually showing ads. And so there's pretty much always some fraud detection services running that are taking all of the data about the real-time bids, what's happened in auctions and all of that, and cleaning it. They're marking it as things that they consider fraudulent, stuff that's bot traffic, stuff that's not bad, and cleaning it, and they're updating the data. And so we support that kind of update process as well, and backfilling is always a thing. There's always some amount of backfill when you're dealing with data, even with a stream. And so we can do that. And then this goes into the next slide a little bit, but offline processing. This is commonly called separation of compute and storage, but we've added recently this notion of asynchronous queries. And this is data that is kept basically in an object store. And so the cost of it is basically aligned with the cost of just data being in an object store, but you can still query it. You can still get access to it and query. And so it's dealing with the two things. When you have this, the immediate infinite zoom experience that we were talking about, that interactivity is really important. If the first time you load it up, you get empty panels or you get a spinner because you're dealing with a cold start problem, that makes your experience really bad. It makes the application experience bad, and so you don't want that. You want the data to be readily available, and that is handled by these hot queries that are mentioned here. But data that happened 2 years ago, you've got a business analyst that cares about it once a month. Someone looks at it once a quarter. You don't need that to be hot and available with no cold start, because that person's only going to look at it for a while and they're just going to run a query, walk away, and then come back to it. So you don't need to pay for it being immediately available at that. And this tends to be a pattern as well. As data gets older, the immediacy of it becomes less and less important. It can be a much more higher latency element, and so what we've added is a very natural progression. You can decide the point that you want the data to go off into being only queryable via async queries at a slightly higher latency penalty. And then another thing is kind of focusing in on use cases and use case needs. And one example of this is a time series analysis. With time series specifically, people want to do interpolation because, like, if you think of sensors, sensor data out in the real world, the sensors, they try to generate data every minute, every 15 minutes, every second, whatever. Sometimes they don't. Sometimes they're off. Sometimes they have hiccups. Sometimes there's issues with the network and they can't send it, and the data doesn't actually get there. But you still want to be able to see kind of what happened. You want to understand what goes on. People need things like linear interpolation and other stuff like that. There's also very commonly area under the curve styles of computation. So like a time-weighted average or basically derivative style processing, where people are trying to understand and analyze what's going on with the data. You get that in a time series. Usually you then want to combine that with other time series. You want to add them together, subtract them, multiply them. There's a whole algebra of interacting with time series. And one of the things that we make possible is we have functions for all of this stuff that basically thinks of a time series as an independent data type and allows you to work with time series and do algebra of time series objects themselves. But this is kind of just one notion of the type of thing that we can do to optimize different use cases and looking at data in order to really deliver and drive after that immediate infinite zoom experience where you can see it at the high level, zoom in, get all the way down to the raw events. So with that, Imply, this is the summary slide. It's repeating all the things that I've said. Imply delivers the immediate infinite zoom experience on the data. You see it at the high level, just like I showed in the demo. You see it at the high level, you can drill down, you can get down to whatever level of granularity is actually in the data, down to that very raw event level. And so you can do the high level analytics, you can get needle in the haystack, you can do everything in between. It enables real-time and historical insights. The connectivity to the stream means that the data you're looking at is up to date. You don't have to ask yourself, oh, if I wait an hour, will it be better? It's up to date. It's telling you what's happening right now already. The interactivity of that experience requires queries to respond quickly. Without that, you're just going to have the spinny, or going back to Google Maps, when you zoom in and you just get the blank panels, it's really annoying. And then there's the visualization. So with that, here's the thank you slide. We have a workshop that we are setting up. You can find out about it at this QR code. If you go there, you can sign up. Well, thank you, everybody.